Hello there. Our research focuses on use of prompt-based learning for code-mixed text classification. Code mixing is a linguistic practice where words are borrowed from one language and adapted into another language without affecting the overall context. There are two types of code mixing. First type refers to text that consists of words alternating between two languages. As you can see in the example, second and third words are in Latin, whereas other words are in Sinhala. Second type involves text written in one script being transliterated into another script by swapping letters in predictable ways. In the example, a single sentence is transliterated into Latin characters. Code switching, also known as language alternation, occurs when individuals switch between two or more languages within a single conversation or situation. Here in the example, the two sentences alternate between Sinhala and English. Let's look at why code mixed text classification is useful. Code mixing is commonly observed in social media conversations and various other forms of communication. Code mixed text classification has several practical applications. Researchers and organizations can gain valuable insights into user sentiment and behavior across different languages. It helps in understanding customer satisfaction and identifying common issues, leading to actionable improvements in products or services. It enables the measurement of public sentiment towards brands, products, or specific events across different language communities. Content moderation systems can be significantly enhanced by accurately identifying and handling code mixed content. Code mixed text classification can be leveraged for personal product recommendations as well. Prompt-based learning is the latest paradigm in natural language processing, where a natural language task instruction and a few examples are appended to the task input. Let us explain about prompting using a simple animation. Note that a manual prompt and a manual verbalizer are used in this animation. When an input is given, it is appended to the template to form the prompt. Then the prompt will be fed into the pre-trained language model. In the animation, XLM Robota is used as the language model. The model will then predict the most suitable answer for the mask position. Then the answer will be sent to the verbalizer. Verbalizer checks whether the answer is in one of its answer spaces. Then that answer will be mapped to the relevant label, which is the classified sentiment of the sentence.
Problem and motivation. Classifying code mixed text poses a significant challenge in natural language processing. One effective approach to improve the performance of downstream tasks, especially in low-resource language settings, is prompt tuning. However, most existing research has primarily focused on monolingual prompts, overlooking the specific needs of multilingual tasks. No previous work has explored the use of prompting for classifying code mixed text. The lack of dedicated multilingual prompts hampers the ability to leverage the knowledge encoded in pre-trained language models for code mixed text classification. Additionally, the presence of transliterated tokens further complicates the task, as they can be incorrectly identified by the pre-trained models. Research objectives. In our research, we have set out to accomplish three main objectives. Firstly, we will conduct a comprehensive evaluation of different basic prompting strategies to assess their effectiveness in classifying code mixed text. Building on these findings, our next objective is to enhance the performance of the selected strategy, refining it for code mixed text classification. Lastly, we will focus on improving a multilingual prompting model to effectively classify code mixed text considering the properties of code mixed data. Basic prompting strategies. Manual prompt and manual verbalizer. This approach involves using manually defined human-readable templates and verbalizers, and because of that, no training is required with this method. Since there is no training, this performs the worst out of the basic strategies. Manual prompt and soft verbalizer. In this approach, we use manually defined textual templates as prompts. However, instead of manually defined tokens in the verbalizer, we utilize soft tokens, which are trainable parameters. During the training phase, these soft tokens are optimized. These soft tokens can cover a larger answer space compared to manually defined tokens, providing more flexibility and accuracy in generating outputs. soft prompt and manual verbalizer. This approach combines a soft prompt with a manually defined verbalizer. The soft tokens of the prompt are initialized using a human-readable template, and during the training phase, these soft tokens are optimized. The verbalizer, on the other hand, is manually defined. This approach helps coming up with a better suitable prompt for the task. Soft prompt and soft verbalizer. This approach represents a combination of soft prompt and soft verbalizer. Both the soft tokens of the prompt and the soft tokens of the verbalizer are optimized during the training phase. It has been identified as soft prompt and soft verbalizer is the best performing strategy among the basic prompting strategies for code mixed text classification. Since both the soft tokens of the prompt and the soft tokens of the verbalizer are optimized during the training phase, they achieve a language agnostic representation. In our research, we proposed 3 models based on the soft prompt and soft verbalizer approach for code mixed text classification. The first model is adapter prompt. The second model is dynamic prompt. Lastly, we propose a combined model, dynamic prompt plus adapter prompt, which leverages the benefits of both models. Adapter prompt. Adapter prompt is a technique that utilizes bottleneck modules called adapters to enhance the task-specific knowledge capacity of pre-trained language models. By incorporating adapters into a pre-trained language model, we can leverage their capabilities during prompting, leading to improved performance. In our research, we further improve the model's performance by employing the adapter drop-in technique, which helped identify the optimal adapters required to capture task-specific knowledge effectively. Through the integration of adapters, we aim to enhance the capabilities of pre-trained language models and achieve better results by giving a task-specific representation to the pre-trained language model. Dynamic prompt. Dynamic prompt is a technique employed to provide a script-specific representation in code mixed text classification. It involves training separate soft prompt soft verbalizer models for each script category, exclusively using sentences from the respective script. This approach reduces the variability of script-wise performance. This makes it easier to handle each script individually, rather than relying on a single pre-trained language model to handle all scripts simultaneously. By adapting dynamic prompt, we aim to improve the accuracy of our code mixed text classification tasks by leveraging script-specific representations.
Now let's move on to the novel prompt tuning method that we propose for code mixed text classification, which is dynamic prompt plus adapter prompt. This leverages a combination of dynamic prompt and adapter prompt techniques to enhance their performance. Dynamic prompt provides script-specific representation, enabling the models to understand the characteristics of different scripts more effectively. Adapter prompt, on the other hand, focuses on improving task-specific functionality, allowing the models to excel in specific classification tasks. There are 2 ways that adapters can be integrated into the language model. First one is script-wise adapters. In here, adapters are integrated into the language model separately for each script-based model. This allows for fine-tuning and adaptation specific to the characteristics of each script category. Next one is shared adapters. In here, same adapters are shared between each script-based model, enabling the models to leverage common task-specific functionality while benefiting from the script-specific representation. As you can see in the architecture diagram, there are 3 separate models for each script: Latin, single and mixed, which share the same language model. Shared adapter approach is included here. The input is prepended to the soft prompt based on the script of the input before feeding to the language model. Overall, our proposed model combines the advantages of dynamic prompt and adapter prompt techniques to optimize both script-specific understanding and task-specific performance, resulting in improved classification capabilities. Now let's move on to the demonstration of the proposed solution. Our proposed solution contains multiple code mixed text classification models, and we will now demonstrate the capabilities of the best performing model for classifying the code mixed text. Let's take a look at 5 example input sentences and the classification tasks they are used for. The meaning of the first sentence is, I like to watch cricket matches. When we input this sentence, the sentiment is identified as positive, and since all the characters are in English, the script is identified as Latin. The second sentence means, I don't like sweet food. Upon inputting it, the sentiment is identified as negative. As this sentence contains characters in both English and Sinhala, the script is identified as mixed. Moving on to the third sentence, its sentiment is identified as neutral, and it is written in the Latin script. The meaning of the fourth sentence is, Tortoise and rabbit are good friends. Upon inputting it, the model identifies the sentence as humorous. Since all the characters are in Sinhala, the script of the sentence is identified as Sinhala. The meaning of the last sentence is, Candy is very beautiful. The model identified this sentence as non-humorous. As it contains characters in both English and Sinhala, the script is identified as Our exploration of code mixed text classification has highlighted the untapped potential of prompt-based learning and its impact in this field. We identified that soft tokens facilitate a language-agnostic representation by decoupling the models from specific languages, thereby proving to be effective in code mixed text classification. Our experiments have revealed performance variations caused by the inclusion of multiple scripts, as the models struggle to effectively handle the complexities introduced by diverse scripts. To address these challenges, we propose a novel approach called Dynamic Prompt plus Adapter Prompt, which leverages the prompt tuning to enhance code mixed text classification. Our novel method surpasses the performance of both XLMR basic fine-tuning and adapter-based fine-tuning, showcasing its capabilities in this domain. In summary, our findings underscore the importance of exploring prompt-based learning techniques and the significance of handling multiple scripts in code mixed text classification. With the introduction of Dynamic Prompt plus Adapter Prompt, we have made significant advancements in improving the accuracy and effectiveness of code mixed text classification models. Thank you.